Unified dynamics.
At the subatomic level, the universe has a distinct left and right-handedness, a property physicists call chirality. The particles that make up your body, the planets, and the stars behave differently depending on which way they are oriented. We naturally expect a perfectly mirrored, balanced reality. Instead, the subatomic world plays favorites. It is strictly lopsided. Imagine zooming in on that lopsided universe, past the quarks, past the smallest known particles, down to the absolute bottom layer of reality. Many physicists suspect that if you go deep enough, space isn't a smooth void, but a discrete, pixelated grid. Watch what happens if we assume space isn't continuous, but snaps into a rigid lattice. This creates a notorious paradox in physics, known as the Ginsburg-Wilson Problem. If you try to map those lopsided, left and right-handed particles onto a rigid, pixelated network, the math breaks. When standard models force asymmetrical particles onto a symmetrical grid, the equations produce severe errors. The geometry collapses under the contradiction. We clearly exist. Our particles are distinctly chiral. So if the bottom layer of reality is a discrete grid, we shouldn't be here. For years, physicists had to choose between a pixelated geometry and the reality of particle physics. But a framework called unified dynamics found a mathematical loophole. That loophole starts by throwing out the standard square grid. Instead, unified dynamics builds reality out of an interconnected web of tetrahedrons, known as the K4 simplex. You start with a single 4-point shape, and it multiplies outward, forming a dense, self-contained network. When energy flows through this specific tetrahedral web, it naturally sorts itself, attempting to partition into distinct left and right pathways. The structure handles the asymmetry by separating the left and right sectors into mirrored subnetworks, all while keeping the main web perfectly intact. But executing this split without triggering a geometric collapse requires a strict accounting system. The universe has to track every single topological force. The discrete geometry supports asymmetry, as long as it can perfectly pay the mathematical cost of doing so. That payment is governed by one strict rule. The total topological force of the entire universe must sum exactly to 0. In this framework, creating matter is a geometric distortion. Because these tetrahedrons form loops, the strength of that distortion, its amplitude, is measured as a fraction of a circle's rotation. Every unit of matter carries an amplitude of exactly +1/3 pi. To state at 0, the network creates a shadow signal, an equal and opposite -1/3 pi. This is how the Ginsburg-Wilson roadblock is bypassed. The lopsided matter doesn't break the discrete grid because the invisible topological information zeroes it out. The matter twists into a chiral shape, and the system stays stable, safely isolated by that opposing information side. You can have local asymmetry in your particles and your biology exclusively because the global ledger of the universe remains frozen at exactly 0. This forces us to rethink the vacuum of space. We usually imagine the void as an empty box waiting for things to happen. But in unified dynamics, 0 does not mean empty. The void is actively churning. It is a compressed state, continuously folding and unfolding upon itself in perfect tension. It's an evaluated state, where the potential for matter and its opposing topological information are tightly bound together, working to maintain that 0 ledger. Which means you and I are not objects sitting inside an empty container. We are the visible mathematical residue of a conservation law actively playing out. Our lopsided, complex existence doesn't break the rules of a discrete universe. It is the direct, necessary consequence of a system that must always balance exactly to 0.
Don't forget to like, subscribe, and share. And keep questioning reality.